Hello everyone. In today's topic, let us understand about vector diagrams of loaded alternator. In order to understand the vector diagrams of loaded alternator, we must understand what is armature reaction. So armature reaction with respect to DC generators is nothing but the effect of armature flux, that is armature flux, on the main field flux. But when we consider the alternator, here the power factor, that is phi, cos phi, plays an important role. Power factor of the load has very considerable effect on the armature reaction. Hence, we must understand there will be three cases. First case, when load power factor is unity, one, that is unity. Second one, when load power factor is 0 lagging. And third one, when load power factor is 0 leading. These are the three cases which we will be studying or understanding. Now, what is a vector diagram of a loaded alternator? In order to draw the vector diagram of a loaded alternator, we must consider E0. E0 here, E0 being no load EMF. It is no load EMF. So this being the voltage induced in the armature, which was in the absence of components RA, XL and armature reaction. So we can say that it represents the maximum value of the induced EMF, because in the absence of this, so it represents the maximum value of the induced EMF. Now let us assume E being the load induced EMF. So this is the induced EMF. This is nothing but after allowing for the armature reaction. So E is definitely, once we remove the armature reaction, E is vectorically less than E0. So E is vectorically less than E0 by value by I into XA. So E0 is less than I into XA. So let us draw the vector diagrams here. So considering the first case, load power factor is unity. So let us imagine first case wherein this is your 0 terminal, next current I, at the same terminal we have voltage V. Now this voltage V has to supply two components as we discussed. So this is our E0 without any. So this is your I 0, then this is the point V. So this is the loss I into RA. So similarly here we have IXA and IXL. These both the terms is nothing but IXS. Here this term is I into ZS. This is IZ and this is IRA. So as we considered this being the unity power factor load, in the unity power factor load, initially this is your no load EMF. For the given current, this is your no load EMF and this is your load induced EMF. So in induced EMF, both voltage, this is your voltage, and current are in the phase. Now when we consider the second case, lagging power factor, as we know in the lagging power factor, the voltage is in the line, then current lags this voltage by an angle phi in the lagging power factor. Other than this factor, all other terminals remains to be same here, just like the other case. So once we consider this, So here again it is supplying IRA, then this is your IXA and IXL. So this is your lagging power factor. Similarly, when we consider the load leading power factor, here voltage V and the current lags voltage by an angle phi. All other terminals remains to be same, but all other parameters like your RA, XL and XS, the angle changes as per the leading, lagging and unity power factor. So here V is nothing but the terminal voltage. So generally this terminal voltage is vectorially less than E0 by I into Zs. So what is Z? From the above equation, Z is nothing but square root of RA square plus XL square. So it may also be written as ZA. So what is I? I is nothing but your armature current per phase and phi is your load power factor angle. So we can write for UPF, that is unity power factor load, EPH is nothing but whole square root of VPH from the vector diagram, VPH plus IARA whole square plus IA XS whole square. For leading and lagging, it will be EPH is equal to square root of VPH cos phi plus IRA square plus VPH sin phi plus or minus IA XS square. Now when you observe, for unity power factor it is VPH IR square. That term is same here, VPH, but we are considering two terms here, cos and sin theta, because load will be both lagging and leading. So VPH cos phi IR square, but in the second term VPH sin phi plus or minus IA square. Plus sign is used for lagging and minus sign is used for leading power factor. So this is about your vector diagrams of loaded alternator.